All right, guys, 1.4, properties of exponents. I think you guys are going to like this chapter, or I guess this unit, this lesson, this section of a chapter. We're dealing with the same thing over and over again. We are just dealing with exponents, something that you have experience with. We are skipping the exploration stuff. We're not going to go over that kind of thing here in a video. So the lesson here, a couple of vocabulary words I want to remind you about. Power. When you see this word, remember what it's referring to is a number or a variable that has an exponent, like x to the fourth power, or 7 to the third power, or -3 to the -2 power, all right? This term right here is considered, they call it a power. We usually reference the number up here as the power. We call that number up there, that's called an exponent. That number tells me how many x's are being multiplied together. And I'm going to say that again because it's a lot different than the definition you're used to. How many x's are being multiplied together? That tells me I'm doing x times x times x times x. Everyone says, oh, that means you multiply x 4 times. No, you don't. You multiply it once, twice, 3 times. But there are 4 of them being multiplied together. That's what x to the fourth means. And that number up there we call an exponent. The x right here, remember that we call the base. The base is the big number at the bottom. The exponent is the little number at the top. And good news, all of you, no scientific notation. We're not going to get into that this year. We're not interested. We don't care. That's not true. It is interesting. We do care, but we don't this year. So, couple of rules that you're going to need to know because you're going to use them all year long, guys. The rules that we talk about today of everything we do this year, this is going to be in every homework. Okay, this is going to come up over and over and over again. So there are things that we need you to get good at. First rule is the zero exponent rule. It tells me anything raised to the 0 power equals 1, okay? 4 to the 0 equals 1. 8 to the 0 equals 1. -3,627 raised to the 0 equals 1. 1/4 equals 1 if it's raised to the 0 power. Anything to the 0 is 1, is equal to 1, except for 0. 0 raised to the 0 does not exist. That's undefined. The number 0 cannot have an exponent of any kind, not just 0. Okay, negative exponents. If I have something like, well, let's read you what the book says because we're practicing using the book, right? For any integer n and any non-zero number a raised to the -n is the reciprocal of a to the n. Ooh, reciprocal. Anybody remember what reciprocal means? That means you flip it upside down. So if I have a number, there's an example right here. 4 raised to the -2 power is equal to 1 over 4 to the 2nd power, which is really cool because to get rid of a negative exponent, all you have to do is move it up or down a fraction, okay? If I have 17 to the third power, -3rd power, that becomes 1 over 17 to the 3rd power. If I have a negative on the bottom, let's say I have x on top and I have y to the -3 on the bottom, I can move that to the top and that becomes x times y to the 3rd power on top. Now there's nothing left on the bottom. I'm allowed to do that. I can move the y to the 3rd power on top and get rid of the negative sign, okay? You can move anything up or down and you can change that negative to do so. So here are some examples. So example A, 6.7 to the 0. It doesn't matter that there's a decimal. It doesn't matter if it's a fraction. Anything to the 0 is equal to 1. All right? Example B, -2 to the -4th. All right, well, I told you to get rid of the negative up there in the exponent, I move it to the bottom. So that -2 to the -4th is equal to 1 over negative 2 to the positive fourth. And that's important, okay? The negative with the 2 doesn't change to a positive. The only negative that changes is the negative on the exponent. And this one I can actually simplify because negative 2 to the fourth power is what? 2 times 2 is 4, times 2 is 8, times 2 is 16. A negative times a negative times a negative times a negative is a positive. So that equals 1 over 16. All right, let's simplify another one. We're down here now, 4x to the 0, example number 2, divided by y to the negative 3. Okay, I'm going to tell you the way I do these problems. First thing I do is I get rid of negative exponents. I don't like them. They just cause issues and problems and hurt my soul. So we're going to move that y to the negative 3, we're going to move that to the top, and we're going to put it with the 4 and the x to the 0, and that y to the negative 3 now becomes y to the third. And there's nothing left on the bottom of the fraction, so I don't need to put anything there. There is no more bottom of the fraction. Well, technically there's a 1, but we don't have to write that because we would have to write that for every number. So x to the 0, what does that become? That becomes the number 1. So this just becomes 4 times 1 times y cubed, which is just 4y cubed, and you're done. All right, what I want you to do, I want you to pause the video really quick, and I want you to try these monitoring your progress problems right here. Number 1, number 2, number 3, and number 4. I want you to try those really quick. Yes, actually pause the video. Yes, actually try the problems. Figure out if you know how to do this yet or not. Okay, welcome back. So negative 9 to the 0, anything to the 0 power, that's a 2-second problem, right? That's a 1. Doesn't matter if it's a negative, doesn't matter if it's infinity, it doesn't matter what it is. If it's a number and it's raised to the 0, it equals 1. 3 to the negative 3 can be rewritten as 1 over 3 to the third power. And 3 to the third power is 3 times 3, which is 9, times another 3, which is 27. Okay, number 3, negative 5 to the 0. Ooh, we got to be careful with it. Look at them trying to trick us. Look at them being sneaky. And then 2 to the negative 2 on the bottom. All right, so I told you I don't like negative exponents, so I'm going to get rid of that first. So I'm going to rewrite this as negative 5 to the 0, and then the 2 squared is going to move to the top, 2 to the positive 2. Now here, guys, there's a very big difference between this example and number 1. They almost have something in common, but there's something that's a little bit different, and that's the fact that, look at this negative 9. See how it is inside parentheses? This negative is not inside parentheses. So I'm not taking negative 5. I'm not taking negative 5 and raising it to the 0. I'm taking 5, raising it to the 0, and adding a negative to the front of it. So 5 to the 0, that's 1. But there's a negative in front of it, so I have to put a negative in front of it. And then 2 to the square, 2 to the second power, 2 to the square. 2 squared is 4, so this becomes negative 4. Please, please, please be really, really careful with that negative sign. With our exponents, if that negative is part of the base, it will be in parentheses, okay? If you see negative 2 to the 4th without a parenthesis, then this is 2 to the 4th power. 2 times 2 times 2 times 2, and then you put a negative at the front. If this is negative 2 to the 4th power, that means negative 2 times negative 2 times negative 2 times negative 2. Make sure you know the difference. Okay, moving on. I'm talking too much. Simplify the expression. 3 to the negative 2 multiplied by x to the negative 5 over y to the 0. Oh, what a good question. Okay, let's get rid of the negatives. I want to move that to the bottom. I want that 3 to the negative 2 to go on the bottom. I also want to move this to the bottom. The x to the negative 5, I want to move that down and call that x to the 5th power. And then I already have a y to the 0 on the bottom. So there's nothing left on top. Now, I can't just leave it blank like I did when there was nothing left on the bottom. I've got to put a 1 right there. Otherwise, it's not a fraction. It just looks like my problem has an umbrella. All right, so 1 on top. 3 squared, well, that's just 9. X to the 5th is just x to the 5th. And y to the 0 is 1. So my final answer becomes 1 over 9x to the 5th power. I hope that's what you got. If not, try again. Okay, next rule. Product of powers property, okay? So in words, I'm just reading down here, to multiply powers with the same base, we add their exponents. Okay, guys, I'm a math teacher, and even reading that sentence is hard for me to do. I like to look at the numbers. If I have 4 to the 6th power multiplied by 4 to the 3rd power, now my base is the same. It's a 4 and a 4. They're being multiplied together. It tells me that I actually take the exponents and add them together. That 6 and the 3 get added together, and this becomes 4 to the 9th power. Okay, well, let's do some more of those. I think I've got a little sticky note right here so I don't take up valuable space anywhere else. So if I have 3 to the 2nd power times 6 to the 4th power, I can't do that. We're doing the same base. I meant 3 to the 4th power. My bases are the same, so that becomes 3 to the 6th power. I add those numbers together. If I have 7 to the negative 3 multiplied by 7 to the 8, I can still add those together. Negative 3 plus 8 is positive 5. If I have x to the 11th and x to the 14th and x squared, all being multiplied, 11 plus 14 is 25, plus 2 is 27. All right, easy, easy. Quotient rule. So that's what happens if I multiply them together. What quotient means divide. So what happens if I divide powers that have the same base? Look at this example. 4 to the 6 on top and 4 to the 3rd power on the bottom. That tells me to just take the top and minus the bottom, and I end up with 4 to the 3rd. That's kind of a cool rule. So let's try a couple more. If I have 3 to the 4th on top and 3 to the 2nd power on the bottom, that becomes 3 to the 4 minus 2, which is 3 squared. If I have, I'm using the same examples from earlier. If I have 7 to the negative 3 on top and 7 to the 8th power on the bottom, ooh, I like this one. I have a couple of ways of doing this problem, but let's go with the rule that we just learned. That becomes 7 to the negative 3 minus 8, which is 7 to the negative 11. And you know I don't like negative exponents, so that actually becomes 1 over 7 to the 11th. If you can see another way to get that same answer, awesome. Go for it. Whatever's on top subtracts whatever's on the bottom, okay? And really all you're doing, guys, is you're canceling things out. It's kind of like having, if I have x to the 4th and x to the 7th, that's kind of like having x times x times x times x on top, and then x times x times x times x times x times x times x on the bottom. Well, this cancels, this cancels, this cancels, this cancels. So I'm only left with 3 x's on the bottom, and that's all you're doing. X to the 4 minus 7 is x to the negative 3, and if I move it to the bottom, look at what I get. Okay, all we're doing is canceling stuff on the top and the bottom. You've been doing that for a couple of years now in math. All right, power of a power. Now, here's where you start to get mixed up, okay? Because if you're multiplying numbers together, you add the exponents. But if you are, this is probably very bad English, but if you are exponenting an exponent, look, I have 4 to the 6th power, and I'm raising that to a 3rd power. So I'm taking an exponent and I'm exponenting it. All I have to do is multiply my exponents together. So 4 to the 6th power raised to the 3rd power becomes 4 to the 6 times 3 power, which is 4 to the 18 power. All right, so some more examples. X to the 3rd power raised to the 7th power becomes x to the 21st power. x to the negative 2 power raised to the 8. That becomes x to the negative 16. I multiply those together, which becomes 1 over x to the 16th power. If you exponent another exponent, multiply them together, okay? All right, here's some examples, A, B, and C. So example A, 3 squared multiplied by 3 to the 6th power. It tells me that I should add those together. So that becomes 3 to the 2 plus 6, which is 3 to the 8th power. And I have no idea what that is. What is 3 to the 8th power? That's too big for me. I'm okay with 3 to the 8th power. We'll leave it at that. I know a lot of my 3s. 3 to the 3rd is 27. 3 to the 4th is 81. But I don't want to multiply that 4 more times. So we're going to leave it 3 to the 8th power. Actually, does yours have the answer? Oh, it does. 6,561. The book's smarter than me. 6,561. Okay, part B, negative 4 squared divided by negative 4 to the 7th. Well, I told you to take the top exponent and minus the bottom exponent, which equals negative 4 to the negative 5th power. We don't like negative 5th powers, so we're going to move that to the bottom and become negative 4 raised to the 5th power. Now, you are welcome to type that in your calculator. Again, we're not going to take the time to do 4 times 4 times 4 times 4 times 4. You are going to get a negative fraction. The number on the bottom is going to be negative. You can use your calculator to do that. Part C, z to the 4th power raised to the negative 3rd power. So that becomes z to the 4th multiplied by the negative 3. That becomes z to the negative 12, which becomes 1 over z to the 12th power. See, now now math is getting interesting, okay? You start getting into stuff like that, and you have to multiply this exponent in, and then you have to move it to the bottom. Things are starting to pick up a little bit. I want you to try number 5, 6, 7, 8, 9, and 10. Try all 6 of those. Take 3 minutes, pause the video, come back when you think you have the answers. Okay, number 5, 10 to the 4th times 10 to the 6th. My bases are the same. It's being multiplied, which means I'm going to add the 4 and the negative 6. That becomes 10 to the negative 2, which equals 1 over 10 squared, or 1 over 100. All right, number 6, x to the 9th multiplied by x to the negative 9th. Ooh, I like this. So that's x to the 9 plus negative 9, which is 9 minus 9, which becomes x to the 0, which becomes 1. That's a good question. Number 7, negative 5/8 divided by negative 5/4. Okay, this negative is not attached to the 5. Okay, so first thing I'm going to do, I have a negative on top and a negative on the bottom. 5 to the 8 on top and 5 to the 4 on the bottom means I need to do 5 to the 8 minus 4. Now that becomes a negative over a negative, and this becomes 5 to the 4th power. Well, a negative over a negative, do you guys remember what that does? If I have a negative divided by another negative, those actually cancel each other out and it becomes a positive. So my answer is 5 to the 4th power, or that's 625, I believe. Okay, number 8, y to the 6 divided by y to the 7. Well, that's just y to the 6 minus 7, the top minus the bottom, which is y to the negative 1. And I need to move that to the bottom, and that becomes y to the 1. Okay, 6 to the negative 2 raised to the negative 1. Oh, this is another good question. I'm exponenting another exponent. So negative 2 times negative 1 is a positive 2. 6 squared is 36. All right, w to the 12th power raised to the 5th power. I am exponenting another exponent, so that becomes w to the 60th power. 5 times 12 is 60. I hope it's still 60. I don't think they've changed that yet. All right, moving on. One more big topic, and then there's some story problems, but I'm going to let you kind of suffer through those on your own because you can. I believe in you. Power of a product. So If I have numbers being multiplied within a parenthesis and an exponent on the outside of the parenthesis, I have to be really careful how I say this. So look at this example right here. 3 multiplied by 2 raised to the 5th power. It says that I get 3, that turns into 3 to the 5th multiplied by 2 to the 5th. So it's kind of like I take that exponent and I distribute it to everything that's being multiplied separately. 3 to the 5th times 2 to the 5th, okay? So if I were to have, I'm just going to give you one example and then we'll do some below. If I were to have 8x squared times y raised to the 4th power, that exponent is going to get multiplied into all 3 of those. That's going to become 8 to the 4th, x to the 8th power, and y to the 4th power. That exponent gets transferred to everything on the inside. And because the x already had a 2, I had to multiply the 2 and the 4. All right, if I am doing the same thing, but the numbers on the inside are being divided, if I have 3 divided by 2 with an exponent of 5 on the outside, same thing. Everything on top gets the exponent 5. Everything on the bottom gets the exponent 5. So if I had 8x squared over y, and that whole thing was getting raised to the 4th power, the 4 would go to the 8, the x squared, and the y on the bottom. So I would get 8 to the 4th, x to the 8th divided by y to the 4th power. It transfers to everything, okay? So examples. A, -1, I'm right here, -1.5 y to the 2nd power. Well, first things first, the -1.5 is going to get a square, and the y is going to get a square, and that is going to simplify to be what? Positive 2.25 y squared, I think, because 1.5 times 1.5 is 2.25. All right, part B. Let's do this one now. A divided by -10 raised to the 3rd power. Well, that 3rd power goes to the A, and it also goes to the -10 on the bottom. Now that negative is attached to the 10, so it's okay for me to put it inside the parentheses. All right. Do I want to simplify any of this? That becomes a cubed over -1,000. A -10 times a -10 is a positive 100, times another -10 is a -1,000. Okay, part C. 3d divided by 2 raised to the 4th power. Well, the 3 gets the 4, the d gets the 4, and the 2 gets the 4. 3 to the 4th is 81. D to the 4th is d to the 4th, and 2 to the 4th power is, from earlier, I think we said that was 16, right? Something like that. Okay, 2x. I know these are worked out on your paper, in your book. I know that you can already see the answers. I don't care. I want you to see someone actually working through the problem, and you can look at the answers. See, we're double dipping here. 2x divided by 3 to the -5 power. So the 2 gets a -5, the x gets a -5, and the 3 on the bottom gets a -5. And I don't like negative exponents, so I've got to switch those all around. The 3 with the -5 is going to move to the top. The 2 with the -5 is going to move to the bottom, and the x with the -5 is also going to move to the bottom. So this becomes what? 243 on top, and then 32x to the 5th on the bottom. All right, you try it. 11, 12, 13, and 14. I want you to try those problems. Pause the video, and actually try them, okay? When you're done, come back and check out the answers. Okay, number 11, 10 times y raised to the 3rd power. That's 10 to the -3 and y to the -3. So that becomes 1 over 10 cubed y cubed, which is actually equal to 1 over 1,000 y cubed. Okay, -4 over n to the 5th power. Ooh, we got to make a decision here. Okay, so something to remember about fractions. Negative 4 over n. That is the same thing as negative 4 on top and n on the bottom, which is the same thing as 4 on top and negative n on the bottom. You've got to decide, okay, where is that negative, where do you want that negative to go? What do you want to apply it to? Do you want it to go with the 4 or the 5? So negative 4 to the 5th power divided by n to the 5th power. Okay, number 13, 1 over 2k squared to the 5th power. Well, that's going to be 1 to the 5th power on top, 2 to the 5th power on the top bottom, and k to the 10th power, because I have to multiply those together. And then you can simplify that, 1 over 32k to the 10th. And then number 14, 6c over 7 to the negative 2 power. So 6 to the negative 2, c to the negative 2, all divided by 7 to the negative 2. Well, that equals 7 to the positive 2 on the top. The top negatives move to the bottom, and that becomes an unwritable pen. Come on, pen, wake up. What's going on? There we go. 49 over 36c squared. Okay, moving on. You know what? No, you try the story problems. Let's see what you can do. If you struggle with those, you can come ask me questions in class, but I want you to do homework number 1.4, 5 through 43. I want you to just do the odds. If you really want to, I'll let you do the evens. 46 through 48, 57, 63, and then some of the challenge problems, 45, 49, 50, and 65. Those are on the calendar on Canvas. Good luck.